Welcome to drillingcontractor.org. This is Kelly Ainsworth Robinson at the 2018 OTC in Houston. I'm with Paul Neal, Director of Steerable Technologies for NOV, to learn more about the new RSS they're showcasing at the conference this week. Hi Paul, thank you so much for joining us.
Thanks for being here, I appreciate it.
The Vector Edge was designed for performance in North American unconventionals. Could you give us an overview of this technology and what enables its performance in long laterals?
Over the past several years, right, laterals are getting longer and longer, right? And there's a huge need in the market to develop technology that can drill these laterals straighter and faster. And the solution to that is rotary steerables, right? The need is growing, right? The problem with a lot of rotary steerables today, it can be somewhat cost prohibitive to run them, right? So you really need to outweigh the pros and cons. What we've designed and come up with is what we think is the first rotary steerable specific to the high volume market, the North American market, that can deliver these quality boreholes at a cost effective price, right? So there's certain things that we've done to do that. We've leveraged our knowledge in existing technologies. So we've developed motors, directional sensors, and we've taken that technology and embedded that into our system so that we don't have to reinvent the wheel, right? The second thing we've done is we've developed, or we have a very broad, a very good supply chain group. We're a manufacturing company. We manufacture parts, equipment, tools, right? So we're able to get parts delivered efficiently at a reasonable cost. And then the third thing that we've done is basically keep the design scope very tight, right? There's a lot of features you can put in tools to help you drill these holes, but they're not mission critical. So what we've done is we've talked to our customers and determined what are mission critical and what features are nice to have. And we've been very disciplined in not having too much scope creep that would add cost to the system, right? So certain things that we did focus on that helped the tool grow is we wanted a technology that had a full rotating body, right? And the reason for that would be to reduce torque and drag and reduce the occurrence of stuck pipe. We've developed a tool that you can run with a motor, so a motor assist application. We've also developed a tool that's basically MWD agnostic, right? So you can run any MWD system on it. You can run EM systems, mud pole systems, and the tool will still perform. And with that, we've been able to develop a system whereby you can still receive data for the tool without having to add any hardware between the tools or any surface hardware, right? So we're able to get confirmation of received downlinks, minimal tool diagnostics, which basically now helps us get into the final point that was a big focus of ours, is simplicity, right? We wanted a technology that was very user-friendly, and being able to get that information downhole helps our customers understand how the tool is working, help troubleshoot the tool. The way we downlink to the tool is very simple, so the onboarding of new customers can be very fast, which helps reduce the number of people you have on location.
How does the closed-loop control system in this RSS work?
So the tool has sensors that can detect inclination, right? And what happens is the tool is able to steer if it deviates from that inclination. So there's a couple of things you can do. You can pre-program the tool, say, to drill vertical, and if the tool is drilling a vertical hole, then if it starts to deviate, then the tool can steer itself back. If we're drilling lateral wells, you can actually downlink to the tool and tell the tool to hold a particular inclination, and if it starts to deviate from that, then again it will steer itself back. So there's ways that the tool can kind of steer itself with minimal intervention from surface.
Where has this tool been run so far, and what kind of performance have you seen?
Yeah. We've run the tool at our own test facility, RDTC in Navasota, where we've commissioned a rig to test equipment and tools and so on. We do a lot of runs there. We've done tests at the test facilities in Oklahoma. We've done jobs in West Texas. We've done trials in Pennsylvania, Oklahoma, and it's been good. Like, we've learned a lot. We basically understand now and come to the conclusion that the tool design and operating method is applicable and can be used in these sorts of wells. And we've also identified areas for enhancement, right? Flow, wear resistance, and so on. And these are the things that our engineering team is focusing on now to ensure that we launch before the end of the year.
Paul, thank you so much for joining us and giving us a look at the Vector Edge.
Thank you very much. I appreciate your time.
Thank you for joining us on drillingcontractor.org.